Okay, so I may have gotten a little too excited on that last bit when I said jump to 52. Because hopefully, as I was thinking about when I stopped the last video and started doing this one, I jumped to 52. I rewrote the table a little bit to clean it up a bit. And then I went 1, 2, 3, 4, 5, down to 8. And then I jumped, I put ... And I jumped to 52. And I said, okay, sweet, I'm excited. I can figure out this number by starting with that number, 52, and then multiplying by, and then I realized something, that we actually have to know the previous number, which would have been 51. And then in order to know 51, we'd have to know the previous number, which would be 50, 49, and we're gonna be here a long time to do that. Actually, we'd have to go back until we connected to 8. Because once we have 8, we have 9. Once we have 9, we have 10, blah, 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 all the way down through 52. And I think that's not going to be the most efficient way. My chalkboard's not big enough, first of all. I'm going to blame the chalkboard. But I got a better idea. I don't think we need to connect 8 to 52 to figure this out. I think we've got enough information on the board, because I happen to look up and notice something, if that's okay. So this 2, I'm just going to go back to the very beginning. But not the 1, because 1 again is boring, but 1 was important, because 1 got us this 1 down here that helped us get this 2. Even though we didn't really use it, we could have if we had seen the pattern back then. So this 1 gets us this 2. You see this 2 right here? That 2 is the same 2 as that 2. That's exactly how we figured it out. Was we took 3, which is the next number, and multiplied it by the number of ways to deal the previous deck. But then this 2 is also the same as 2 times 1. And I want to use that fact. So what I'm going to do is I'm going to replace this 2 with 2 times 1. So watch what this is going to look like. The 3 is still going to be there. But then this 2 is going to be 2 times 1. And you might think to yourself, okay, that's great, I guess. It still gets us 6. And we didn't have a problem with 6. We had a problem with 52. But if I may beg your patience, let's keep going with this. Check this out. 4 times 6. This 6 is the same as that 6. And that 6 is 3 times 2 times 1. Which means this is 4 times 3 times 2 times 1. And if we keep going, this one, since this 24 is that 24, and that 24 is 4 times 3 times 2 times 1, this is going to be 5 times 4 times 3 times 2 times 1. Now, this might not jump out at you right now, but this is getting me really excited, and here's why. I'm going to erase all this stuff in the middle that we've got so far, and I want you to look just at these results here. And I want you to see, sorry, I changed colors on you there. I want you to see something. Starting from the top to the bottom, these methods of solution here allow us to simply start with the number of cards and not look back. They allow us to just start with that number of cards and then multiply by every number of cards less. So 5 times 4 times 3 times 2 times 1. 720, if the pattern continues, should just be 6 times 5 times 4 times 3 times 2 times 1. And of course, it's going to be, it has to be, because 5 times 4 times 3 times 2 times 1 is the previous one times the next 6. 7 is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. Oh boy, I'm getting excited. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Which means we can now do 52. 52, all we've got to do, and there's no way I get this one out of my head, but all we've got to do is start at 52, and then multiply it by 51, and then multiply that by 50, and then we keep going. You didn't think I was actually going to write all that out, did you? We're going to keep going until we get down to 3 times 2 times 1. And all we've got to do is figure out what all that multiplies to get, and we've got our result. Now, I'm going to have you pause before you grab your calculators and start trying to figure that out. Because the math we just kind of discovered here on this little chalkboard in my garage while it's snowing outside is actually pretty special. It's got a special name called a factorial. And we're going to learn more about that in the next couple videos where we kind of walk through what the factorial is, what it means, what it looks like, what its symbol is, and how it's useful. So let's go inside, where it's a little bit warmer, and look at the factorial and how it applies to our problem here. And we're going to figure out if we should believe JT or not. All right, see you soon.